Hello, everybody. Here's one of your final activities of the year. What you're going to be doing is you're going to be taking these exact triangles that we had from one of the last lessons. These are your special triangles. So I've oriented them the same way that that other video was done with. So you have the 45 up in the upper left, and then the 45 down here in the lower right, and then the 90-degree angle. And this, remember, is part of an equilateral triangle that's been cut in half. So you have your 30 up here, your 60 here, and your 90. Now these can be rotated and turned anyway. It doesn't really matter. We can even flip them over and rotate them. That doesn't make a big difference right here. But what I'd like you to prepare now, pause the video if you need to, is to get ready your unit circle. So now this is a unit circle. I did part of it, but I didn't do all of it because you should have had that done before. I've labeled both the degree measures here and the radian measures. So degree and radians, degree and radians. And you start with 0 radians and 0 degrees. And I label them right here. What we're going to do now is we're going to place this on a coordinate plane. Just your standard coordinate plane like this. The x and y axis. The middle is 0, 0. So your middle is 0, 0. We're going to create ordered pairs for every single triangle that looks like this. So our ordered pairs are going to be, well, what comes over here at the 0-degree angle and 0 radian angle? Not sure. Let's see. If this is 0, 0, remember what we said about the unit circle? The unit circle has a radius of what? Remember? It's a radius of 1. So this ordered pair right here, I'm going to fill this in on the inside the circle. I forget if I told you to put these on the inside or the outside, but your ordered pairs are either going to be on the inside or the outside, and your degrees and radians are going to be on the opposite side. It doesn't make any difference. So this here, this dot is going to be at 1, 0, because that's how it basically works. So a coordinate plane, the unit circle, this is kind of like zoomed in on this little circle right here with all of these radiuses being equal to 1. All right, well, if this is 1, 0, well, what's this one? Well, this is 0, 0, and you're going 1 unit up. So this right here is going to be 0, 1. Now, you're going to do that with these ordered pairs also. But then the question is, what about these guys? Well, that's where our good old special triangle comes in. We're going to shoot at a 30-degree angle in this direction, right towards this dot. Oh no! If you remember correctly from the one that Miss Mullman drew in that video, we had this radius here, this length right here. This is supposed to be 1. The radius is 1 on the unit circle, but our radius was 2. So what do we need to do? We need to shrink this triangle down. Oh, shrink, shrink, shrink. Woo! And there you have it. It's a shrunken version of the bigger triangle. Well, if the bigger triangle had a 2 here, we need a 1 to be right here. I'm going to change colors to green. So if we want this to be 1, actually, let me put it to green. That's back. We want, let's do purple. We want this side right here to be 1 only. So how do you make this become a 1? Well, let's divide by 2. Because 2 divided by 2 gives me a 1. Yay. Well, if you divide this side by 2, you need to shrink everything down by a factor of 2. So we need to divide this by 2. So this side becomes 1/2. And if that side is shrunk by a factor of 2 divided by 2, this side will divide by 2 here. So this side's going to be a radical 3 over 2. So it's basically the same version, just shrunken down half the size, taking a half of every side or dividing by 2. That's what we're going to do here. So now I wonder what this ordered pair is. Now remember, ordered pairs are as you move to graph something on a coordinate plane. Let's say I wanted to graph 2, 3. I would move right 2 and then up 3. 1, 2, 3. 1, 2, 3. So I've moved right 2, up 3. So this is my right and up movement. Well, I'm going to do the same thing here. How far to the right am I moving? I'm moving up until this spot so I can then go up. See, I drew in a little triangle. So I'm moving to the right, an ordered pair of this distance, radical 3, square root of 3 over 2, comma. And how far up do I go? I go up 1/2. This ordered pair happens to be radical 3 over 2, comma 1/2. Now, you may not have these beautiful triangles here, but you can certainly draw in a 30, 60, 90. And then if you had a separate color, that would be kind of cool for you to draw in maybe your, here's this, 45, 45, 90 triangle here. And I just put that one in red. So here's my 45, 45, 90 triangle completely in red. I wonder what that ordered pair is. Now you could probably put your triangle in here in really light version in pencil and then draw in pen or marker your colors. Well, now let's go back to that 45, 45, 90. Here it is again. Uh-oh, I have to flip it over. It ain't gonna match the way we had it. Oh, too big again. So we need to shrink it down. This hypotenuse is radical 2. So let's cut that in half. Well, I'm going to change colors here. You can see what I'm doing. Because if I cut that in half, I would be dividing by the radical 2. That would make this guy, this hypotenuse, equal to 1, which is what I want. Remember, I want that to be 1. So once again, I made a miracle shrunken version of this. Here it is. But I'm going to have to flip this upside down so that I can make it look like this. All right, so let me draw this in. 45, 45, 90. Now remember, this hypotenuse has to be 1. So that's why I did the square root of 2 divided by 2. So if I divided this side by the square root of 2, I need to divide this side by the square root of 2 and this side by the square root of 2. So these sides here can be listed as 1 divided by the square root of 2, or you could choose to rationalize denominators. 1 times the square root of 2 is the square root of 2, and the square root of 2 times the square root of 2 is the square root of 4, which is 2. I prefer this, but both of these will work. Either one of those, they're the same decimal. So the same thing here, I could use this one, or since it's isosceles, it's the same thing, I could use this one. I prefer the square root of 2. You're going to see next year where that comes into play. So if you divided this one by the square root of 2, you need to divide all these by the square root of 2. I'm going to call this the square root of 2 over 2 and the square root of 2 over 2. So once again, how do I get that ordered pair? I move right square root of 2 over 2 and up the square root of 2 over 2. There you go. I'm going to do 2 more for you, and then you're going to fill in the rest on your own. Well, let's go to this 60 guy. Well, this was the third. Oh, how do I get the 60? You know what I need? I need this 1 to be the hypotenuse. So I need to rotate it and flip it around, make it look like that. So if this is 60 degrees right here, if you see that, this is 60 degrees right there, that angle. So now, oh, I got to do this upside down. Let me fill these out. Hypotenuse is 1. The short leg was 1/2. And the long leg was square root of 3 over 2. So the square root of 3 over 2. So now I have this, and I would go to the right 1/2 up the square root of 3 over 2. So my ordered pair would be right, go to the right, this length here, it's short of 1, 1 goes to the edge of the circle. So this is halfway. Does it look like it's halfway? Does it look like that's about halfway to 1? I think so. And then how high do I go? Well, I don't really know what this is. I can tell you this decimal is about 0.86. Does this look like it's about 0.86? If it's 1 would be up here. Because that's like 1 high. Yes, it does. And that's radical 3 over 2. This ordered pair here, and this ordered pair here, and this ordered pair here will be the ordered pairs around the circle of these 3 dots in the middle. I'm going to kind of do 2 of these and let you do the rest on your own. Let's talk about this one. What ordered pair is that? Now, if you had a triangle, I'm not expecting you to do that, but if you had one, great. You could just do like with a root and do this, which I will. But I'm going to pretend I don't have a triangle. And I'm going to draw one because I don't know if you're going to be so diligent in making this. There it is. So this triangle here is a 60-degree angle from this horizontal. So this guy was also 60 over here. They have the same length or the same distance. Let me show you how that works. Here it is here. And I'm going to do this. Watch this. Are you ready? Flip. It reflects over that y-axis. So this will be half. It's the same distance. It's half. However, a coordinate plane, when you're to the left of the origin, it's negative. How high do you go? It's the same height. Radical 3 over 2. It's going up, so it's positive. So this ordered pair here and this ordered pair here will be the same. And these guys all have the same ordered pair, except sometimes they'll have a negative sign. If you go left, it's negative, and if you go down, the y value. And let's do one more for fun. Remember this red one we did earlier? 45, 45, 90. Reflect. Same thing. How far is this one and how far is this one? Well, we peek at them again. Oh yeah, it's the square root of 2 over 2, square root of 2 over 2. Notice how they are the same. However, you're going left, so your x value is negative. What I'd like you to do to finish this, and you just have to submit it, is come up with this ordered pair, this one, this one, this one, this one, this one, and this one. This is the backbone behind trigonometry, which has motion that goes in a circle. So like if you think of this as a Ferris wheel, when you start to study circular motion, gears in cars, Ferris wheels, just a regular tire or wheel, that's kind of where trig comes into play. And also you're going to see next year the seasons, that temperatures that rise and fall, and you're going to see how it's related to this. So all of this will come together next year if you take trigonometry. But this right here is essential. This is your key to what you'll be doing for next year. Thank you so much for listening. Unit circle, trigonometry, congratulations, you're basically done with the class this